In this video, we're going to talk about stoichiometry. Stoichiometry involves using a balanced equation to answer questions about the amount of reactants needed or products produced during a chemical reaction. It gives the all-important mole ratio that's necessary for answering these kinds of questions. Here's a diagram. You'll see there's lots of these around, but what it does is sort of give you an overview of the process. For instance, you might be given the mass of a reactant and be asked to calculate the mass of a product. You would change grams to moles using the molar mass, and then you use the mole ratio, which you get from the balanced equation, to find the moles of the product, and then you go ahead and use the molar mass to find the mass of the product. Or you might be asked something about, you might be given, say, the molecules of a reactant, okay, and then you use Avogadro's number to get to moles, and to moles of the second thing, and then maybe it asks you for the volume of that, and if it's a gas, you can use 22.4 liters. So you can go back and forth between any two substances in the equation, between two reactants, between two products, or between reactants and products. So let's look at some examples. So for instance, calcium carbide reacts with two waters to give you acetylene and calcium hydroxide. Okay, and you've got your mole ratios, 1 to 2 to 1 to 1. Okay, so how many moles of acetylene, this is acetylene, are produced by adding an excess of water? So I got lots and lots of water, I don't have to worry about that, to 5 moles of calcium carbide. So I'm going to start with my 5 moles of calcium carbide. Okay, and since I've already got moles, I'm going to go ahead and do a mole ratio. I'm going to change moles of calcium carbide to moles of the thing I'm looking for, which is acetylene. Okay, C2H2. And I just go ahead and look in the equation, and I see that it's a 1-to-1 ratio. So I just put 1 to 1, and then I'm done. I'm going to 5 moles of acetylene. Okay, so if I start with 5 moles of this, I can make 5 moles of that. Okay, that's just using the mole ratio. Let's make it a tiny bit more complicated. How many moles of calcium hydroxide, that's that stuff, are produced by adding an excess of calcium carbide to 5 grams of water? So we're going to start with the 5 grams of water. Okay, so we've got 5 grams of H2O. So if I have something other than moles, the first thing we do is change to moles. Okay, we're going to use the molar mass of water, which is 18.02. And then I'm going to go ahead and do the all-important mole ratio. Okay, I'm going to change moles of water, which is what I had, to moles of what I'm looking for, which is calcium hydroxide. Okay, so I look at the equation, and it's 1 to 2. Right, so if I do that out, I'm going to get 0.139 moles of calcium hydroxide. How many grams of calcium carbide are needed to react with 10 grams of water? So I'm trying to compare calcium carbide with water. So I'm going to start with my 10 grams of water. Okay. I'm going to change grams to moles of water. Again, 18.02. That's the molar mass of water. Then I do the mole ratio. Okay, there's always a mole ratio, which is why you need a balanced equation. We're changing moles of water to moles of calcium carbide, 1 to 2. And I'm not quite done. I want to change moles of calcium carbide to grams of calcium carbide. So I need the molar mass of calcium carbide, which is 64.10. And if you do that out, you get 8.89 grams of calcium carbide. So you can hopefully see kind of a pattern developing here. Okay, last example. How many liters of acetylene, okay, that's not acetylene, just kidding, psych, this one, are produced at STP. So STP, we're talking about a gas, that means we can use 22.4 liters equals 1 mole, okay? I'm going to start with this many molecules of calcium carbide, all right? So I'm going to go ahead and start with that. 21 molecules. So we're going to change molecules to moles here, molec to mole, and Avogadro's number, 0.022 times 10 to the 23rd. And then, once again, we've got a mole ratio, okay? We're going to change moles of calcium carbide to moles of acetylene, C2H2, okay? And that is a 1-to-1 ratio. And then I'm going to change moles of acetylene to liters of acetylene. Okay, and 1 mole is 22.4 liters as long as you're at STP for gases. Okay, so 18.6 liters. So that's basically how you do simple stoichiometry.